Hello everyone, my name is Dan, and this is the next tutorial in the Getting Started with MonoGame series. Today we're going to be discussing a little bit about how our screens are going to work. So every single game that you know probably has various screens that you can think of, such as the splash screen, the menu screen, and the game screen. And it's likely best if you separate these as much as you can, because you don't want all their logic intertwined and making some huge monolithic class. In this episode, we're going to start by thinking a little bit about how our screens are going to work. Okay, so let's create an interface for our screen. Let's create a new folder. Add new folder. We're going to call this screens, and this is where we're going to put all our different screens. And we're going to start off with our interface. So new item. We need an interface. Is my cursor flashing for you? It's flashing for me, but let's ignore that for now. So iScreen. I'm going to go with the classic C# naming conventions, and every interface is going to begin with an I, and then whatever the interface is for, so screen. Add. And there we go, we've got our screen interface. So there are various things that screens should do. For now, we're going to just put it all here, but eventually we may actually separate it out depending on where we go with the game. So the first thing we want is an update method. So this is the method that will get called when we want our screen to, I guess, update every frame or whatever. It can be for timers, it can be for the actual game loop or various things. So let's just create a method called update. And it's going to take a float. Delta. So delta is going to be basically the time passed since the last frame. We use this in case certain computers are slower or faster than others. If they're slower and we don't take into account the delta, you'll find that people on faster computers actually have a faster game experience. So you usually want to take into account the delta. Because it's an interface, we don't have to specify a body for this method, and it also doesn't have a accessor either. Okay, so void draw is the next thing we want. Now, draw is basically everything the screen can draw. So say you've got a splash screen, our splash screen is going to want to be able to draw an image for our splash. So what we've got at the moment is the splash image. Actually, if we run this, we can see. Okay, so what we've got at the moment is kind of what we want our splash screen to look like. So this image is going to be drawn from the splash screen itself, and we're going to have various screens. So this is going to be the splash screen. So let's close this down. And what did we need for this to get drawn? So it needed access to sprite batch. So we know for a fact now that our draw method is going to need sprite batch. So let's pass that in as well. So sprite batch, oops, sprite batch. Right, let's clean this up a little bit. Okay, so there's our basic interface. We're going to need a little bit more as we get along, but let's keep it at that for now. So the thing we want to do is, in game one, we want to have a screen. So let's create a private iScreen, oops, screen. And then we want to actually create this. So this needs to become something. And the thing we want it to become is a splash screen. So we're going to have to create that as well. So let's create a screen in the screens folder, add a new class, and call this screen. Splash screen, sorry. Splash screen. Like that. And it's going to implement the iScreen interface. As you can see, it's got this little red squiggly saying that we haven't implemented the interface. So let's just Alt-Enter on that and implement interface. And there you go. It brings in your draw method, and it brings in your update method. Just what we need. And now we can actually make use of this. So, back in game one, during, I guess, the load content, we can do screen, which is this up here. And we want to set it equal to the splash screen. So equals to new splash screen. There we go. So now what happens is when we run the game, it runs this constructor first. Then the MonoGame kind of loop kicks in, and it'll go to initialize, then it'll go to load content. When it gets to load content, we're going to set our screen to a new splash screen. And then once we've got this set, This will happen before update or draw is ever called. So once this is set, we can actually start using the screen within update and draw. So by here in update, let's call screen dot update, which takes a delta. We'll deal with that now. So as you can see, MonoGame has this game time object, and this basically has all the data you need about how much time has passed since the last frame. So we're going to make use of that. But the problem is this just has a bunch of time spans in, so we need to kind of turn that into the format we need. And the format we need is basically milliseconds. So we create a new variable, call it delta, and set it equal to game time. Oops, game time. Elapsed game time. So as you can see, it says time since the last call to game.update. It says it right here. That's what we want. And we want the total milliseconds. Gets the value of the current system time span expressed in the milliseconds. That's what we need. So this is equal to the total milliseconds since the last frame. And we want this to be a float, so we want it to be converted to seconds, and we're going to divide that by how many milliseconds in a second? That's 1,000, isn't it? So we go put delta in here now. And then we can make use of delta. Why are you unhappy? Oh, it thinks this is a double. Let's just make it explicitly a float. And also explicitly cast this to a float. Back to variable. There we go. So the problem there was this calculation actually just created a double, and we just wanted the float, so we just had to cast it to a float, and then we can pass that in here. Okay, so screen is now updating with the given delta. So say half a second passes since the last frame, then total milliseconds will be 500. You'll divide that by 1,000, you'll get 0.5, and then we'll send 0.5 into the update, which we can then use throughout all of our screens then to kind of calculate things we need. Okay, so we've got our update done. One more thing we need to do now is also draw it. So here is all the draw logic that we expect to be on our splash screen, so we can just cut that out. We can go and paste that into splash screen. So within the splash screen's draw method, we can paste that logic we did during the other episode. And we just need to fix a few things. So as you can see, we've now got a bit of an issue. Sprite batch doesn't exist. It's just because it's named differently. We just need to use this one. So copy that and replace all these sprite batches. And also splash image doesn't exist. So we're going to sort this out in just a second. Let's go back to game 1. And let's call our screen.draw and pass in the sprite batch. Now that's all you need within game 1 itself. It's going to set a screen, and then once that screen's set, it's going to update it, and it's going to draw it continuously until we change it or whatever, until the game exits. Right, so what do we need? So within splash screen, you can see we need access to the image. Now, the image is here at the moment. So one thing we can do is we can pass this directly in, which might not be such a bad idea at the moment. So let's do that. So when we're initializing our splash screen, let's just pass in the splash image, like so. And then obviously this is complaining now because we don't have a constructor that kind of matches these arguments. So let's go into splash screen and let's create a constructor. ctor, enter. Oh, that doesn't work in Visual Studio clearly. ctor.tab. Oh, there we go. Okay, so splash screen now needs to take a texture 2D. So texture 2D and splash image. And let's create a private field. So private texture 2D splash image, and this is read only. If it gets set in the constructor, you can make this read only, which is what we want. In the constructor, you can set splash image equal to splash image. And there we go. We've got access to a splash image now. As you can see, this red line's got it. It means it's got it, which is great. Some other things we've got to fix. Basically, the size of withdrawing. The size of drawing it is not accessible. So graphics doesn't exist within splash screen. So we need a way to access the size of the screen. Let's create a constant for this for now, and we'll fix it up later. So Within game one, let's create two constants. Let's create public. Let's not make them constant. Let's make them static. So public static int screen width. Let's make that 1280. And public static int screen height. Make that 720. And then we can make use of this. So because it's static, we can access these statically using game one. So within splash screen, let's change this here to use game1.screen width and game1.screen height. Now, anytime those two variables change, this image will actually resize accordingly. A couple of references missing. We're making use of rectangle here. It doesn't know what it is. Basically, we need to import Microsoft.xna.framework because that has the rectangle in it, so we use that. That also should have fixed color as well, which is perfect. Just what we needed. Okay, so if we run this at the moment, it will work. It will draw it. There is a problem, which we will discuss once I run it. So let's clean up and run it. There you go. Okay, so the problem is our screen window is not actually 1280 by 720. It's much smaller than that, so we do need to fix that and make this window the size we want. So let's close that. Okay, so once we've got these two static methods, we have to apply these to our graphics device. So when we create our game, we've got this new graphics device manager here, and this basically keeps a bunch of information about our window and our window size and things like that. So let's make use of this now and set things we need. So within initialize, we want to set graphics.preferred back buffer width equal to basically this class's screen width, so screen width, which will be 1280. Same for height. Oops, I cancel that. Preferred back buffer height. Here we go, that one, and equal to screen height. Now this won't show immediately. We need to actually apply these changes because you set these properties, but the graphics device doesn't know that it needs to update the screen size. So let's just tell it that you need to update it by doing apply changes. It's a method. Call that. Okay, so when we run the game, we're going to create a graphics device manager, and once the window is up and running and we have initialized, we're going to set our width and height equal to these two here, and then apply those changes so the window will should be the size we've indicated here. Run it. And there we go. We've got a window that is 1280 by 720, just what we wanted. And we've got also our splash image, which clearly isn't the best. We can probably do a little bit about that by just having a quick check in splash screen. So instead of stretching it, let's just create it in at 0, 0. So let's remove this sprite.draw. Let's do it again. Let's do sprite batch.draw, and we want to pass in our texture, which is splash image. Now, alternatively, to a destination rectangle, you can actually pass in a vector too. So the difference is rectangles will also give information about the size of the image. And vector 2 will basically just use the image size itself. So whatever the splash image size is, that'll be used. So let's just pass in a vector 2. And let's set it equal to 0, 0. The color can be color.white. Say no color, no tint. And there we go. We've got our splash image at position 0, 0, which is the left side of the screen, and the top side, it'll be in the top left of the window. And the color.white indicates that we don't want to tint it. So let's run it again. Okay, that's much better. Okay, so one more thing we can do is actually get this directly in the center of the splash screen. And to do that, we need to set the origin point of the image. So by default, images within MonoGame, the origin is set to the top left corner, so it'll position anything relative to the origin. Now, if we set the origin to the center, we can actually position this much more accurately. We'll want it in the middle of the screen. So let's do that. Let's just create a temporary vector here called origin. and make that equal to a new vector 2. And the origin is equal to half the splash image. So the splash image dot width divided by 2, f, splash image dot height divided by 2, f. So this is now saying the origin we want it to be in the center of the image. Okay, so with our origin, which is in the center of the splash image, we need to make use of this. So let's call spritebatch.draw again. Now there are a few overloads here, and one of them actually makes use of an origin when drawing, so we'll use that one. The first is always the texture. So this is the splash image, the first argument, comma. It has a destination rectangle. We don't want that. We want to pass in a position. So the position will be a new vector 2, and we're going to pass in the center of the screen. So let's create that with game1.screenWidth divided by 2, and game1.screenHeight divided by 2. That'll be the center. And then what's next? We got, which is the one we need? Let's have a little look for these. Okay. So you can see they've got position and source rectangle. We don't need that. This question mark means it's nullable, so we can just pass in null. The next argument is a color, so let's pass in the white, comma. The next argument after that is a float, so 0f. Then it's our origin, so we can pass in our origin vector, which we created. Comment, comma, and then scale. Scale is 1f. That'll mean just the default size. Sprite effects. This is an enum, so we just use none because we don't want to flip it or anything. If you want to flip your sprite, you can use flip horizontally or vertically. For this, it's none. Comma again, and then the layer depth, just go for 0. It doesn't matter, we have nothing of importance. And there we go, we've got our new sprite batch call. You can see it's a lot more involved than the one without an origin. But this will just ensure that our image is now directly in the center of the screen. Why? Because we're setting its position to the center of the screen here, and we're saying its origin is the middle of the image, so it should draw it directly in the middle. And there we go, directly in the middle. Got some black bars here, which we'll sort out next episode, but I hope that helped. If you like this video and you want more, please like and subscribe, leave some comments if you have any ideas of where you want to go, and I'll see you all next time. Thanks. Bye-bye.